All right, last part of this question, part D. The first question is show that G prime is this. So that's a good question. That's just straightforward derivatives. Make sure you follow all of your rules. So this is looks like a product rule. So G double prime we're looking for, right? So G prime, just rewrite this for you. So it is a product rule. So we're going to go first e to the negative 2x, which is that times the derivative of the second. 3 times f of x. F of x is the same as y, so it is implicit. It's just times f prime of x. And plus 2, the derivative of f prime of x is f double prime of x. Complete the product rule. The derivative of e to the negative 2x is e to the negative 2x times negative 2. And then we just have the second factor. So it doesn't look like this yet. You can see that in the simplified version, there's only one, there's an e to the negative 2x factored out, so that's what we're going to do. Factor out a e to the negative 2x, you're left with 3 f prime of x plus 2 f double prime of x minus 2 times 3 f of x plus 2 f prime of x. Remember, that's the whole quantity. So you're going to have to distribute that negative 2. So it's minus 6 f of x minus 4 f prime of x. And we're going to combine like terms. So we have negative 6f of x, 3f prime of x minus 4f prime of x is a negative 1f prime of x, and plus 2f double prime of x. And hopefully that's what they said it was supposed to look like. I forget. And that looks good. So we got that. Next is, does G have a local minimum x equals 0? Justify your answer. Well, for local minimum, first of all, we have to show that 0, x equals 0 is a critical number. So this is G double prime. Critical number is where the derivative equals 0. So the first thing we're going to do is plug in x equals 0 to G, which I think we did back here. Yes, we did. So G prime of 0 is 0 from part C. So let me So that means it's a critical number. Now we have to figure out if that critical number produces a minimum or maximum. And you can see if the derivative changes signs, or you can use the second derivative test. Obviously here we want to use the second derivative test because we have the second derivative. So you're going to plug that critical number into the second derivative. So we have e to the 0, which is 1. So I'm looking at this, times negative 6 times f of 0 minus f prime of 0 plus 2f double prime of 0. So now we have to figure out what all that stuff is. f of 0, oh look, everything's here. 2, -3, and 0 in that order. So 2, -3, and 0. 2, -3, and 0. So here we have that's less than 0, obviously. So G double prime of 0 is less than 0 by the second derivative test. You don't have to state second derivative test. You can just say since G double prime of 0 is less than 0, we have a relative max. If a negative second derivative at a critical number produces a relative max. So before I end this, I'm going to go back up and make sure I answered the question. The question was, does G have a local maximum of x equals 0? The answer is yes, it does. And this is why.